Good morning. My name's Rob Hummel. I'm president of Group 47. DOTS stands for Digital Optical Technology System. First, let me tell you what DOTS is not. It is not holographic storage. It is not magneto-optic storage. It is not etching, engraving, or ablative in its nature. It is not some form of Super CD, DVD, Blu-ray. Basically, it is not your mother's optical storage media. DOTS is a digital storage media that is archival for no less than 100 years. It's non-magnetic, chemically inert, immune from electromagnetic energy, including EMP, and can be stored in normal office environments or extremes ranging from -9 centigrade to 66 degrees centigrade. It's a unique phase change alloy that it's sputtered onto archival tape, for example, PET, PEN, or aramid. The special DOTS alloy does not use any of the elements of germanium, selenium, and tellurium in the manufacture of the alloy. Data is represented as optical bit pattern media. DOTS can also record visible text and imagery. That's any imagery, including QR code or other symbology. Adaptable to different formats, DOTS is a low-cost, secure, environmentally friendly storage system to truly archive data long-term. It is not something that needs to be invented. Group 47 has acquired all of the patents and technology transfer that Eastman Kodak spent over $80 million developing. The DOTS alloy and support are both chemically inert. It does not have any demanding environmental requirements. Humidity and temperature swings do not affect the media. In Battelle Class II accelerated life testing, after the equivalent of 94.5 years, there is no detectable degradation to the media. Eastman Kodak performed those tests, and Lord knows why they stopped at 94.5. They couldn't have taken it all the way to 100 years. They actually stopped at that point because Kodak withdrew the funding at the equivalent of 94.5 years. It's also immune from petrochemical, salt water, and any base material. It is not immune from acid, and when we subjected the media to 4 hours of exposure to Sprite soda, the alloy had noticeably degraded, so no dipping the media in Coca-Cola or any type of acid. The method employed for recording to the media is this. A laser writes to the media by heating up the alloy to a temperature that causes the index of refraction of the molecules to change. As you can see in this image here, the phase change causes the shiny surface of the alloy to appear dull. When scanned under polarized light, even greater contrast between the alloy and the written area is achieved. The paradigm shift that is happening here is that DOTS creates a true, eye-readable visual representation of the data. The data is retrieved with an imaging system. An interpretation of the data is performed using standard image processing techniques. Because we create an image of the data, we can also write human-readable text, as seen in these slides here. Each reel of tape or cartridge will have a Rosetta leader that, in microfiche scale text, will contain detailed text and images on how to build a DOTS reader and information on how the data is represented. In the future, if no hardware is available, as long as cameras are available, you will still be able to recover the data. While it would be very tedious, at least it wouldn't be impossible. I should also add, since there isn't any contact with the surface of the media, either when writing or reading, there's little or no mechanical wear on the media surface. Bandwidth and density. We will be able to write the full width of the tape in a single pass. No serpentine recording will be necessary. In the prototype, we will be transporting the tape at only 30 centimeters per second, and at that rate, we'll be recording data at 120 megabytes per second. By the next generation, we will have sped up to 1.2 meters per second versus 5 meters per second in current magnetic tape, and we'll be recording at 250 megabytes per second. And then, within about 21 to 24 months, we'll get to our next generation. We will be recording at data rates in excess of 1 gigabyte per second. And the initial density we expect to have is somewhere between 750 gigabytes to 1 terabyte. That's an LTO form factor of tape. about half-inch wide tape, around 800 meters long. By the way, the prototype will be using off-the-shelf components. There's nothing to invent. DOTS uses available technologies. Further development is an engineering challenge. Now, as far as working with DOTS, for the users, they won't have to do anything different. Procedures and systems you have in place today will continue to be usable. DOTS has capabilities that are unique to the media that are available for new development, but that can be addressed in the future should people so desire. Because it uses image processing, you're always backwardly compatible to Generation 0. Because it's archival, you never have to migrate again. Migration becomes a choice, not a requirement. Because there are no special environmental controls, it saves massive amounts of energy. DOTS is high performance, truly archival, low maintenance. It can survive benign neglect and will result in significant cost savings. Also, it can be used on credit cards, ID badges, etc. Dan Rosen, our Chief Technology Officer, is here with us today, and we look forward to talking to you further during the deep dive sessions this afternoon. Thank you very much.